All right, we're back. And this time we're going to talk about operations with complex numbers. We're going to talk about addition, subtraction, multiplication, and division. So let's just look at the 4 operations in standard form, just to remind ourselves. So operations of complex numbers in standard form. Ooh, oh well. All right, so addition. Addition and subtraction really easy. Addition and subtraction. So let's say you got 3 plus 7i plus 7 minus I. Remember, that's just basic combining like terms. So think about what it would be. And like I said, you just combine like terms. The parentheses don't matter because you just have a 1 being multiplied. There's an invisible 1 here, and there's an invisible 1 here. So when you do the distributive property, it wouldn't change. So just combine your like terms. 3 plus 7 is 10. 7i plus negative I is positive 6i, and you're done. Whenever you add, subtract, multiply, or divide a complex number, you should always get complex numbers. So subtraction would be the same way. If I had 5 minus 3i minus 2 plus i, you could just do it right now and say 5 minus 2 is 3, and negative 3i minus I is negative 4i, and be done. But remember what's happening behind the scenes. The first set of parentheses have an invisible 1, so you distribute that. You still have 5 minus 3i. Second set of parentheses have a negative 1. So when you distribute that, you have negative 2 minus I. And then, again, you combine like terms and you get that. So addition and subtraction, like I said, not a big deal. What about multiplication and division? So it's not that big a deal either, but if you're going to say multiply 5 plus 2i times 3 minus 4i. First of all, one thing just to keep in mind, again, a silly mistake that's often made, compare this example, the first one with addition, to the multiplication. A lot of students will see this addition and then start to FOIL like you would down here for the multiplication. But remember, this has an addition sign in between, so you're just combining like terms. This has an invisible multiplication sign in between, so multiply. And for this, you multiply, you fully distribute. So you're going to distribute the 5. 5 times 3 is 15. 5 times negative 4i is negative 20i. Then you distribute the 2i. 2i times 3 is positive 6i. 2i times negative 4i is negative 8i squared. And then combine your like terms, you're going to get 15 minus 14i minus 8i squared. But remember, you should always get a complex number as an answer. And right now it doesn't look like one, but that is because of the I squared. Remember, I squared equals negative 1. So that is negative 8 times negative 1, which means that's going to be plus 8. And then the 15 and the 8 combine, and you have 23 minus 14i, and you're done. You get a complex number. And notice I keep putting them in standard form. I'm putting the real part and then the imaginary part. Even for the answers above, same thing. Real, imaginary, real, imaginary. Remember, always put them in that order. So that wasn't so bad. That finally brings us to division. And so division, if I have 3 minus 2i divided by 5 plus I, how do we do this one again? Remember, this is where you use the conjugate, complex conjugate. So you're going to multiply top and bottom by the conjugate of the bottom. So 5 minus I over 5 minus I. You're just multiplying by a form of 1. Remember the giant 1, so you can do this. And wow, this is going to be fun because now you have to multiply these two complex numbers on the top and these two complex numbers on the bottom. So it's a problem like this. Twice. Yay! All right, so on the top, I'm going to skip some steps. I mean, here, this multiplication problem, this had all the detailed steps. I'm going to skip a little bit. Just when I'm multiplying these two terms with the I, 2I times negative 4I, that's negative 8I squared, but we know that's going to give us plus 8. So I'm going to do that same kind of thing here. Just jump right to that. So when I go ahead and distribute the 3 times 5 is 15, then negative 3I, negative 10I, and then negative 2I times negative I would be positive 2I squared, but then that's going to turn into a negative 2. On the bottom, now remember you're multiplying by conjugates, so you actually can take a little shortcut. Remember when you multiply conjugates, these two middle terms always cancel out. So all you have to do is 5 times 5 and I times negative I. First times first, last times last. So 5 times 5 is 25. I times negative I is negative I squared, which is going to turn into a positive 1. But I still have to simplify this a little bit. I can combine like terms in the numerator. 15 minus 2 is 13, and then minus 13I, and then that's all over 26. But remember, I have to write it in standard form. Right now it's not in standard form, so I'm just going to separate it. And 13 over 26, that's just 1/2. So I'm going to have 1/2 minus 1/2 I, and voila. There we go. So if we look at these 4 operations, not bad. Addition and subtraction, so easy. All you have to do is combine like terms. So you don't even have to show any work. But with the multiplication and division, a little bit of a tedious process. Not bad. Division's worse than multiplication, definitely, but yeah, doable, not horrible. Okay, so now let's look at trig form and see how this works. So, well, let's see here. Let's do operations of complex numbers in trig form. All right, so let's just mix them up. Let's see, addition and subtraction is going to be similar. So if I have 3 times cosine pi over 5 plus I sine pi over 5 plus 7 cosine pi plus I sine pi. Let's say I was going to do those. Well, I'm looking at this, I'm not quite sure what to do. I mean, I could distribute the 3 across here, and then I could distribute the 7 across here, and I don't think I'm going to have any like terms to combine though. So what do I do from there? Well, let's see what this is going to look like. So I'll have 3 cosine pi over 5 plus 3I sine pi over 5 plus 7 cosine pi plus 7I sine pi. Yeah, I don't have any like terms. Oof. Well, here's what you're going to have to do. And we're not actually going to do it. But I'll do it a little bit. You're going to have to convert it essentially to standard form. So 3 cosine pi over 5. I got to change my calculator first of all to radian mode. And then 3 cosine pi over 5. That's about 2.427. And then I have the I can't do anything with the I on the calculator, so I'm just going to do 3 sine pi over 5. So I'm going to have 1.763, but then I still have the I. And then 7, well, cosine pi, well, we should be able to do this. Cosine pi is -1, so that's going to be -7. And sine of pi is 0. Yes. So we're just going to have 0 for that last term. So then combine my like terms. 2.427 minus 7 is 65.42. Oh, hang on one second. I had a 7. That doesn't make any sense. Let's try that again. 2.427 minus 7. -4.573 plus 1.763i. So I have an answer, and it's in standard form. However, I started off in trig form, so my final answer really should be in trig form. Oof. All right, you're going to have to convert here. I'm going to do this off to the side here. So remember, r is the square root of a squared plus b squared. That's a, and that's b. I'm just going to go ahead and do that. So that's about 4.901. And then if you think about where this is going to be in quadrant 2. You're going to go negative 4.573 on the real axis and then up on the imaginary. So this is going to be in quadrant 2. So I have to keep that in mind. So when I do theta is tan inverse b over a, be 1.763 divided by negative 4.573. So I'm going to get theta is about negative 0.367. But remember, I have to add pi to put it in quadrant 2, because that is not in quadrant 2, that's in quadrant 4. So add pi, and theta is about 2.773. So I finally have my answer in trig form, in the right form. So it is going to be r cosine theta plus I sine theta. Addition and subtraction, like I said, is going to be the exact same thing. They pretty much suck in trig form. If you get to leave your answer in standard form, it's not so bad. But if you have to convert it back to trig form, it's awful. Let's look at multiplication and division, though. So I'm going to scroll up here. Now I'm going to go to a new page. Okay, multiplication in trig form. I'm actually going to derive this. So it's going to be kind of long, but you're going to see it's going to work out nice. So I'm going to let z1 equal r1 cosine theta 1 plus I sine theta 1. And z2 equal r2 cosine theta 2 plus I sine theta 2. Okay, we're going to multiply these guys. It's going to get long, so I'm actually going to start all the way over to the left. I'm going to move this over. Okay, z1 times z2 is going to be those two things multiplied together. r1 cosine theta 1 plus I sine theta 1 times r2 cosine theta 2 plus I sine theta 2. All right. Well, I can multiply the r's together, and then I have the other quantity that I'll have to FOIL. So it's going to be r1, r2, and then cosine theta 1 plus I sine theta 1 times cosine theta 2 plus I sine theta 2. All right. I'm going to have to FOIL. Let's get ready. So I'm going to do the cosine theta 1 times both terms. I'm going to do the I sine theta 1 times both terms. And just to shorten things up a little bit, when I do the last part, when I do I sine theta 1 times I sine theta 2, remember I'm going to get the I squared, which is -1. Okay. I still have the r1, r2 though, I can't forget that. So I'm going to do cosine theta 1 times cosine theta 2 plus I cosine theta 1 times sine theta 2. Excuse me. And then I multiply the I sine theta 1 by both terms. So I sine theta 1 cosine theta 2. And then in this last part, I'm going to have the I squared, which is -1. So it's going to turn into minus sine theta 1 sine theta 2. Whew. How is this going to help? Trust me, it's going to be wonderful. It's going to be like magic. Okay, so I'm looking at this. The real part is actually going to come from this plus this. So I'm going to group the real part together, and then the imaginary part is going to come from this and this, because they both have the i's in it. So still have the r1, r2, but now I'm going to group the yellow part together. So I have cosine theta 1, cosine theta 2, minus sine theta 1, sine theta 2. So that's all from the yellow terms above. And then when I look at the green part, they both have an I in them, so I'm actually going to factor out the I, and then I'll have cosine theta 1, sine theta 2, plus sine theta 1, cosine theta 2. So this all comes from the green part in the previous line. Hopefully it's starting to look familiar. Their identities. The yellow part, that's the sum difference formula for cosine. That is the same thing as cosine theta 1 plus theta 2. That's all the yellow part. And then the green part, that's our sine identity. I sine theta 1 plus theta 2. Holy moly. Look at that. It may not seem as magical yet, but that is going to be great. So I'm going to summarize this. If we look at what we got, if we have Z1 be R1 cosine theta 1 plus I sine theta 1, and Z2 is R2 times cosine theta 2 plus I sine theta 2, this is the product. All you do is you multiply the R's and you add the thetas. And that's it. And then we could prove this for division, but it's a little more cumbersome. You would do the exact same process. It's just a little more cumbersome because division, you have to multiply by the conjugate and all of that good stuff. So I'm just going to summarize them on the next slide, and we'll take a look at them. And then we'll look at some examples. You can see just how great it is. Okay, so here it is summarized. So little vocabulary, just so you know. The R, that's the radius, for obvious reasons. And then the theta, when we're talking in trig form, this is actually called the modulus. You're never going to be tested on this, but just so you know. So if you take a look, when you multiply complex numbers in trig form, you multiply the radii and you add the modulus, the arguments. If you're dividing, you divide the radii and subtract the arguments. Isn't that beautiful? Here's what I mean. Here's how great it is. Okay, so let's look at, okay. Let's multiply 5 cosine 20 degrees plus I sine 20 degrees times 17 cosine 40 degrees plus I sine 40 degrees. So if you want, pause the video and take a look and see if you can figure out what it's going to be using the formulas I gave up above. And we're going to go ahead and do it now. According to the formulas up above, you multiply the radii. So 5 times 17, 85. And then you add the angles. 20 degrees plus 40 degrees is 60 degrees. Done. Isn't that great? It's so awesome. Here's as tricky as it's going to get. Like, seriously. If you have 10 cosine 200 degrees plus I sine 200 degrees times 14 cosine 320 degrees plus I sine 320 degrees. All right, so again, if you want to try it, go ahead and pause the video, and we're going to take a look at it together. Multiply the radii. 10 times 14 is 140. Add the arguments. 200 plus 320 is 520, so you have cosine 520 degrees plus I sine 520 degrees. Except we're not done. Can you see why we're not done? Sorry, the angles. The angle is just too big. It's bigger than 360. So you have to subtract. Take away 360. And you're going to get 160. All right. So we had an extra step in there. But that's it. The only other thing that could make it more complicated is if the angles were in radians, then you probably have to deal with common denominators and fractions. So, for instance, if we look at division, let's say we had 42 cosine, actually let's just do the one above. 20 degrees plus I sine, oh wait, but I wanted radians. I'm going to take that away and say, I don't know, how about pi over 3 plus I sine pi over 3. And we're going to divide by 12 cosine 2 pi over 4. Now I need a common denominator. There we go. Plus I sine 2 pi over 5. All right, not a big deal. Divide the radii, so it's going to be 42 over 12. Reduce that in our final answer. But then we're going to subtract. You have to do pi over 3 minus 2 pi over 5. Let's just do that off to the side here. Pi over 3 minus 2 pi over 5. Get a common denominator of 15. So you have 5 pi over 15 minus 6 pi over 15. So it's going to be negative pi over 15. We can take care of that right now too. That's not between 0 and 2 pi. So now let's just add negative pi over 15 plus 2 pi. That's going to be 30 pi over 15. So it's going to be 29 pi over 15. All right. Put it back in our final answer then. So cosine 29 pi over 15 plus I sine 29 pi over 15. Let's reduce that 42 over 12. 6 can go into both of them. So we have 7 over 2. 7 halves cosine 29 pi over 15 plus I sine 29 pi over 15. We have a little more work because of the radians. But other than that, it's pretty good. So let's just quickly recap. 4 operations: addition, subtraction, multiplication, and division. If you are in standard form, addition and subtraction, definitely the way to go. These are much easier when it's in standard form. Multiplying and dividing, yeah, kind of a toss-up. I mean, it's not so horrible, but when you compare it to multiplying and dividing in trig form, I would say multiplying and dividing in trig form definitely win. Addition, where's my addition one? That one pretty much sucked. I wouldn't even, I mean, if you can avoid it, avoid it. Sometimes you can't, but. So that's this lesson in a nutshell. And then next class, or next video, we will get to powers and roots in trig form. And that's where this really comes together. All right, see ya.